Hello and welcome to another episode of X and Y. This lesson is on the nature of roots. I'm going to explain where it comes from, what it actually means, and then go through a few examples. First of all, when you're asked about the nature of a number, what they're actually asking is the number real, non-real, rational, irrational, and so on?
If you are struggling to identify number types, please follow my link, watch the video on identifying number types, get help, and be a better mathematician.
Right, so roots, solutions, and x-cuts are all synonyms. So when you're asked about the nature of a root, it is literally asking whether the x-cuts of, in our case, a parabola, are non-real, real, rational, or irrational. So where do I find these mysterious roots? How do I determine its nature? And what does it all mean? Let's find out. When determining the nature of roots of a quadratic function, you use a portion of the quadratic formula called the discriminants and sub in a, b, and c values. Now, in previous lessons, I showed how to complete the square and then how to find the quadratic formula. We complete the square in order to express a parabola in its turning point format. I've completed the square of this trinomial already, which means over here we have it in the turning point format. Now, if we look inside this bracket, we can see where the equation x equals negative b over 2a comes from in order to determine the x value of the turning point. Let's see what happens if I continue solving this equation for x. Okay, now pay attention. I'm going to subtract this term from both sides, and then you'll be able to see where the quadratic actually comes from. Now, both these terms share a common denominator, which is why it's usually written as everything over 2a. But I'm going to keep them separately for the time being, and then we'll come back to it. Let's look at an example. If I have the function y equals x squared minus 2x minus 8, we can see that minus 8 is the y-cut, and if I factorize it, then positive 4 and negative 2 will be my x-cuts. If I want to find the turning point, I can either complete the square or use x equals negative b over 2a, solve for x, sub x back into the function, and get my turning point. But I want to show you a slightly easier way. You see, a parabola is symmetrical between any two horizontal points. So I already have my x-cuts, which are at minus 2 and positive 4. Now, what's the distance between negative 2 and positive 4? 6. So if I want to find the middle, I just halve 6, which is 3, which means 3 units up and 3 units down is going to then find my line of symmetry, which is then also going to be the x value of the turning point. So now, I take that 1, I sub it in, and I get minus 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, voila. And now it's just a case of joining the dots. My y-cut was over there, and now I just join. So let's examine the nature of the roots. As I said earlier, roots, solutions, and x-cuts are all the same word. So what do we notice if we look at the roots? Number 1, they are real, right? Because they exist, I can see them. Number 2, they are rational, because minus 2 and 4, they're rational, right? And number 3, the roots of different numbers, which means they are unequal. If I look at the quadratic formula, there's a square root in the formula called the discriminant. This part of the equation gives me the information about the roots of a parabolic function. Generally, it's taught without the root, but I'm going to keep it there just so that you can see what happens after I sub in the a, b, and c values. So, the square root of 36 is 6. Now, where have we seen 6 before? That's right, it was the distance between the x-cuts. Now, if I take another look at the quadratic formula and divide by 2a, so I'll take the 6 and I divide by 2a, I would get 3. So now, upon further investigation, this part of the formula represented the turning point. So in other words, what the quadratic formula is actually telling me is I take the turning point and I go up 3 or down 3. So in our case, we had 1. If we go up 3, we get 4. And if I go down 3, I get minus 2. So what this is actually saying, what that is, it's a distance between the x-cuts. So how can I tell the nature of roots of a quadratic function without drawing it? Well, if the square root part of the quadratic formula is the thing that tells me about the x-cuts, I simply have to look at what's inside the root, and then after substituting my a, b, and c values, and then figure it out. Because in this case, 36 is a perfect square. So the distance between the two x-cuts is 6, which is real and rational. And the fact that there is a distance between the two roots means that the roots are unequal because they're not the same number. Let's take a look at another example. In this case, factorizing this trinomial is more challenging, so I use the quadratic formula to determine the roots, and it gives me 0.64 dot 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 and negative 4,64 dot dot dot. Right, now, both of these are irrational numbers, and if I drew the graph, it would look something like this. Now, when I put the values into the discriminant, I get the square root of 28. Now, do you know what the square root of 28 is? No, because it's not a perfect square. So now I have roots, which means they are real. The problem is that they are irrational. But the fact that I have a distance means that the roots cannot be equal. Let's have a look at another example. In this case, when I factorize this trinomial, I get x minus 2x minus 2, which means my x-cuts are positive 2 and positive 2. On a graph, it would look like this. Now, when I use the discriminant, the answer is 0. Why? Well, like I said earlier, the discriminant is the distance between the x-cuts. So what's the distance between 2 and 2? Nothing. I still have a real root because it exists, and it's rational. The square root of 0 is rational. But they are now equal roots because the distance between them is 0. Let's take a look at another example. For this trinomial, when I use the quadratic equation to try and solve for x values, it says math error. Why? Well, if we look at the graph, what are my solutions? There aren't any, because there are no x-cuts. So when I use the discriminant, I end up with the root of negative 8. And what is the square root of a negative number? That's right, it's non-real. So let's put all of this together. Alright, so when you are asked about the nature of roots, just use the discriminant with the root until you can see what's going on, and then you can just figure it out afterwards. Because obviously, here we go. If it's a positive inside the root, you know it's going to be real. If it's a negative inside the root, it is going to be non-real. If it is a positive, now it's either going to be rational or irrational. If it's 0 or a perfect square, it must be rational. If it is a non-perfect square or imperfect square, it'll be irrational. If it is 0, it means it has equal roots because there's no distance between the x-cuts. If there is a distance, it means you have unequal roots. And there you go.